Okay, so it's time to start talking about access modifiers, and in particular private, public and protected, as well as package private. So what we're going to do is, now to see why you'd want to restrict access to the fields and methods in your classes, what we're going to do is implement a very simple and frankly seriously flawed bank account to demonstrate that. And just before I go on, in case you're wondering about the color scheme, you've probably noticed if you've been following along, the last few videos have been looked a little bit weird with some of the buttons and so forth not fitting. There's currently an issue with IntelliJ 15 when you're trying to size up fonts, and for some reason when I select Darkular, which is the dark theme, it doesn't happen. So I'm just going to leave it in this mode now. Let me know what you think of this. And I find it better to work in this mode, but generally the white background's better for videos, but we'll see how we go with this anyway. Okay, so first thing we want to do is create a class. We're going to create a class called account. So I'm just going to do what we normally do. Select the package and create a new class, call it account. Okay, so that class is going to have firstly a string, private string, account name. It's also going to have a balance. Actually, what we're going to do, we'll change that to a public. Because we were talking about access modifiers, it's important to understand this. So we'll also make the balance 0, that's also a public. And public array list. Array list integer for transactions. And transactions on the account. We're going to create a constructor, and the constructor will accept account name. So we set the field account name to whatever's passed, and we also initialize the transactions. So this.transactions equals new array list integer like so. So it's just creating an empty array list ready for us to start adding records. And we also need a getter for the balance. So getter balance. So that's our base accounts class. And just to confirm the transactions, very, very basic. What we're going to do is store the amounts as a positive number where it's a deposit and a negative number for withdrawal, and put those in the array list. Okay, so next what we need is some methods to support deposits and withdrawals. So what we're going to do is implement those, and then we're going to get the account class to calculate the balance as well. So firstly, the deposit, public void deposit, and pass a parameter of the amount we want to deposit. We check if the amount's greater than 0, and if it is, we're going to add that, transactions.add amount, and we also want to add that to the balance. So the balance gets incremented by the amount that was passed to this method, and we'll put a message to the effect to say amount deposited, balance is now plus this.balance. Else, what we're going to do is, if it wasn't greater than 0, we'll print out a message just to say cannot deposit negative sums. Okay, so that's our very basic deposit method. So let's now write the withdrawal one. Similar, obviously the money's coming out or being deducted from the balance. So public void withdraw, pass an amount as well. Int withdrawal equals minus amount. So we're converting it to a minus, remember, because a negative number we're going to assume is a withdrawal. And we'll put if withdrawal is less than 0, this.transactions.add withdrawal, this.balance equals, we're adding withdrawal, remembering it's going to be a minus number, so we can still use the plus there. And we can say amount withdrawn, balance is now plus this.balance. Else, message, you cannot withdraw negative sums. So that's our basic withdrawal method. Again, it's checking, converting it to a minus because we're going to pass a positive amount, and then we're setting it to a minus amount, and then we're checking to see if it's less than 0, which means we can withdraw. We're going to add that to the transactions, bearing in mind a negative number we're considering to be withdrawal. We're adding the balance, or adding withdrawal, I should say, to the balance, but bearing in mind it's going to be a minus number, we can still do that and give a reflected updated balance, and then updating how much is what the current balance is after the withdrawal, and we're just showing an error message if there was a problem. So next, the last method we're going to create here is going to be calculate balance. So public void calculate balance. So we start with a balance of 0. Then we put for int I this dot transactions. So we're going to go through all the entries in our array list. And this dot balance, add to that. Bearing in mind that will work for plus or minus numbers. And then we'll just print out a message to say calculated balance is plus this dot balance. Like so. So that's our method there now for calculating the balance, where we start on 0 and we can go through and tally up all the transactions to come up with what the balance is after all of those. Okay, so to do some testing, we're going to go back to our main class and then into our main method. And we'll start with account, and we'll call it Tim's account equals new account Tim. Let's do some do some transactions. So Tim's account dot deposit 1,000. Tim's account dot withdraw 500. Tim's account dot withdraw minus 200. Tim's account dot deposit minus 20. Some of these are obviously wrong. Tim's account, oops, with semicolon in there. Account dot calculate balance, and we'll print out a message. Balance on account is plus Tim's account dot get balance. Very, very straightforward, as you can see there. Okay, just fix that typo up and we'll run this. And we can see that we started out 1,000 deposit, balance is now 1,000, 500 withdrawn, balance is now 50. When we get an error on the next line because we're trying to withdraw a negative sum, and we can't deposit a negative sum either, as you can see there. So calculating the balance is 500, which is correct, and the balance on account using the getter is also 500. So everything works, and probably in a real application, the withdraw and deposit methods would also log somewhere to provide an audit trail of activity on the account. But notice that we've declared everything as public. This is the thing I wanted to point out. So going back to account, you can see everything's public, the account name, balance, and transactions. And what that means is this allows any program using the account class to modify the balance directly. And we can do that by inserting the following code into main. So under this line here, if I added another entry, Tim's account dot balance equal 5,000, and run that, we've now changed the account balance to balance on account is 5,000. Now that's obviously not good being able to do that, but the bank would spot the attempt at fraud by checking the transaction list, except we can also modify that as well. So we could do something like Tim's account dot transactions dot add 4,500, and then we could do Tim's account dot calculate balance again. So I could run that. We now have a match, you can see, of the account balance, but also there's now an entry in the transactions array list as well. So in a well-designed system, the transactions list, in this case the array list, should only be modified by the deposit and withdrawal methods. So by allowing access to the transactions list from outside the class, and the balance for that matter, we're introducing the potential for errors in the program, or in this case, for fraud. So obviously, here the fraud would be a deliberate act on the part of a programmer, but it's also the case that objects can be altered by mistake because the implications of doing so aren't apparent. In other words, the programmer didn't really understand the ramifications of what they're doing. The point is, if you expose fields of your classes, then anyone using the class will reasonably assume that they can manipulate the value of those fields. And because this bypasses the methods you've written to use those fields, as you can see in this case, your classes may no longer behave as you intended them to. So you actually lose control over that. So in other words, by making the account name, balance, and transaction fields public, what we've done is we've allowed them to be modified outside of the account class. And it's a simple fix. All we need to do is change them to public. So I come back here and change these to private. private, private. So after we do that, when we go back to main, we actually now get errors, as you can see on the screen. So really the only way we can access those directly is by using, in this case, the deposit and the withdrawal methods, which means it's a lot more secure. So let's now have a look at the 4 access modifiers, and we'll discuss their effects, and then we'll produce some code to put these into practice. So access control is granted both at the top level or at the member level. So at the top level, what you can do is you can make your classes and interfaces public or package private. You can't define a private class at the top level, as we can see if we try. So let's try and do that. So I'll try and create a new class, and we'll call it private class. So I come along here and try and firstly add a constructor. That will work. But if I change this public to private, we'll get an error. Modifier private is not allowed here, and that's telling us we can't have a private class at this level, at sort of the top level of this file. And let me just shoot over to the slide now where we just talk about this a little bit more, just to confirm what can happen at the top level. So basically at a top level, only classes, interfaces and enums can exist at the top level. Everything else must be included within one of these. So public means that the object is visible to all classes everywhere. Whether they're in the same package or have imported the package containing the public class. But package private, what that means is the object is only available within its own package and is visible to every class within the same package. So package private is specified by not specifying, if that makes sense. In other words, it's the default if you do not specify public. There's not actually a package private keyword as such. You just remove public and leave it as a class, and then you get package private for doing that. So moving on. And this is an example of a top level public class, as you can see on the screen there. So standard public class definition there, and with a public constructor. Top level public interface, very similar as you can see there. Again, the public keyword, the word interface, and then obviously the name of the interface in this case. Now a top level package private class, I mentioned that you remove the public identifier. You can see on line 3 there's no public there, it just says class. So that's how you define a package private class. And likewise for interface, package private interface, removing the word public again. Now at member level, this is once we're actually in the class itself, public, so using public at that level, at the member level, has the same meaning as the top level. So in other words, a public class member or field and public method can be accessed from any other class anywhere, even in a different package. And we saw that when we were using the main method to update the balance manually instead of going through the withdraw and deposit methods. Now package private, this also has the same meaning as it does at the top level. So an object with no access modifier is visible to every class within the same package, but not to classes in external packages. And lastly, private, and we saw that when we changed the fields in the example code, the object is only visible within the class it's declared in. It's not visible anywhere else, including in subclasses of its class. That's very important to know as well. Lastly, protected. The object is visible anywhere in its own package. It's sort of like package private, but also in subclasses, even if they're in another package. So that's why you'd want to use protected instead of private. Okay, so let's go back and look at doing some more coding now. So we've been using our access modifiers throughout this course, and I've briefly discussed the use of private in earlier lectures, but now you've got an almost complete definition of what they all mean. Now I said almost complete because there's one case that we've not specifically mentioned, although it was covered in the lecture on interfaces. That case is part of the solution to our mini challenge. So what we're going to do is I'm just going to delete this private class because we're not going to need that. And I'm going to create an interface. I'm going to new, call it a class, or select class, choose interface, and I'm going to call this accessible. I'm going to close the run window down. So what I'm going to do now is paste in some code. Now note I'm actually deleting this first part of the interface as well, so I'm going to paste it all in. Okay, so the challenge is in the following interface declaration, what's the visibility of 1, the accessible interface, 2, the int variable sum underscore constant, 3, method A, and 4, method B and method C. And what you might want to do is think back to the lecture on interfaces before answering this. So pause the video at this point, and when you come back, we'll go through and give you the answer to them all. Okay, how did you get on? Hopefully you figured it out. So firstly, let's talk about them. So number one, the accessible interface. What's the visibility of that? Well, it's set to package private. So in other words, it's accessible to all classes, in this case in the com.timbachauka package, because that's what I've defined above. The second one, the int, variable sum underscore constant. The visibility was set to public. And what that means is all interface variables are public static final. And again, that was the hint to go back and check the lecture on interfaces before answering. Method C, number 3, step 3, method A on line 19. What's the visibility of that? Well, it's just public. It's just a standard public, and we talked about that. And method B and method C are public because all interface methods are automatically public. So the lack of an access modifier here does not imply package private. So there's a little bit of a trick question there, and that's why I suggested you went back and check on interfaces. So with method B and method C, they're still public because this is an interface. So it's a little bit sneaky, sorry about that, but it's not possible to have anything except public methods in an interface. Now this does make sense if you think about it, because the whole point of declaring an interface is to provide methods that have to be implemented. So if you hide those methods, then any class implementing the interface will struggle to implement the hidden methods, which sort of defeats the whole purpose of using an interface. Now you can make the methods effectively package private by ensuring that the interface itself is package private, as we've done here. Now although all three methods are public, if the interface itself is not visible outside the current package, then those methods obviously won't be visible either. So that's it, you've now got the complete picture. The lack of an access modifier means the default of package private, except with interface methods and variables, which are always public. So that's it. I hope you got a lot out of this video, and I'll see you in the next one.